After you've been doing fMRI long enough, you might realize that the results you get aren't necessarily the ones that you want. And wouldn't it be great if we could just kind of create our own images that had the values that we wanted? Well, you can actually do this from the command line in SPM. Through MATLAB, you actually have the tools at your disposal to create a NIFTI file and fill it in with whatever values you want. Okay, so in here, hold on, got to bring this to full screen. I made a couple small scripts, and really it's up to you to look through them and determine how they work. But I have one that will just create a blank NIFTI. So essentially you just take a copy of an existing NIFTI file. It could be an image contrast, it could be an anatomical image, whatever. Just something that has the dimensions that you want. So what this will do is it will zero out all the values, just create a blank file. And so I'll show you what this looks like. I'm in a typical results folder here, and what I'm first going to do is, this might seem somewhat convoluted, you can do this however you want, but I'm going to copy one of these tmaps into a file called temp. Okay, so now I have this AFNI command that converted it to temp with a brick and a header. And I'm also going to use 3D AFNI to NIFTI to make that an actual NIFTI file. Okay, so I have a NIFTI file, temp.nii, and this first command here, you don't need to use this, but also say you want an entirely blank NIFTI file to begin from the ground up. Okay. So first of all, if I look at this the way it is right now, okay, I've just made a copy of that tmap. This looks pretty standard. But after running this, okay, here, create blank NIFTI. My bad. Okay. If we load it again, you're going to see that everything has been zeroed out. All right. So yeah, everything is blank. Everything has an intensity of 0 no matter where we are. All right, so let's say that we have a simple text file like the one I have right here, temp.txt, and within this file it has an intensity value and then the voxel coordinates. Okay, so 50, 40, 30. These aren't standardized coordinates. What you'll need is to actually open up your NIFTI template, and if you've already warped it to a standardized space, it's fine, but just make a note of the corresponding voxels. Okay, so if my standardized coordinates were 10, 30, 20, let's say, I need to use voxel values of 41, 79, 47 in this temp file. Okay, so I have 5 voxels, and they have different intensities, 4, 5, 7, 10, 500, and different locations, voxel locations. So that's the temp file, and then I'm going to use this script CreateNIFTI to load the image file, in this case a blank NIFTI image I've created, and the text file which has the values of each voxel and what intensity do I want to replace it with. Okay, so instead of having a value of 0, I can make it have a value of 20 or 500, whatever I want. So it's a simple function, just needs an image file and a text file. And remember to pass those as strings. So CreateNIFTI, and I'm going to use temp.nii, and the text file is temp.txt. Not very imaginative, but it works. If I go back here and open up that same temp NIFTI file, okay, so notice it doesn't look like much, but remember I only altered 5 voxels. So if I look at what those are, let's say in 50, 40, 30. Okay, remember to insert that in the voxel field. Okay, you can see that the intensity there is 4, just like it was up here. And you can see it's a little bit brighter right above that. That's because at the coordinates of 50, 40, and 35, the value was 500. Okay. So those are a couple useful tools you can use. Really, it's just to build your intuition about what's going on with these NIFTI files and how you can manipulate them using MATLAB. Can also see how this can be very easily abused if people want to actually create and falsify data. Well, you know, it can be used for either good or bad, but just in this case I hope it's more of a learning tool than something you'd use to make fraudulent. claims with. So it can either be used for a completely blank data set like I just showed you there, or it can be used to overwrite certain values in an existing image. It could be a T-map, it could be a raw epi image, it could be anything that you want to write over. But it's to show you how you use both SPM functions to read in data, overwrite certain values, then write out a corresponding file that has been altered. So hope it's useful. Don't use it for evil purposes.